Hello and welcome, dear viewer, to the next powder episode, the next parser episode. I almost said it's the next parser episode. I'm still at binary expressions. Scrap that actually. And I couldn't figure them out last time. It was kind of embarrassing. I scrapped the whole section of the video, which was just me trying to figure out how to do the parsing. I looked at some old binary expression parsing code that I had, and actually it's super smart, because the thing is, like, the expression that is the least strongly binding, which is plus and minus, you need to parse that first. Because if you parse it first, like in this case, and also you need to parse from the right, so you get less left associativity. So for example, in this case, I want to actually just first of all look at the longest expression I can parse, then the add, and then then the smallest expression in a way on the right side, and that will give me like plus 5 plus whatever is on the left side. And that's also how associativity works. And now here I still want to look for the plus, because if I now look for the plus and parse its left side, and then whatever is on the right side, then like times will bind more strongly than plus, because we parsed it later with lower priority, quote unquote. Like, that's counterintuitive, but that's how it works. At least that's how I've seen it work in my other code, which definitely works correctly in these circumstances. So I think what I need to do is try and parse an addition, or like, yeah, an addition with two terms on the left and right side, and the terms can be or should be multiplications, or they can be another sub expression somehow. I'm not entirely sure. Yeah, it's all kind of weird. So I think what I want to do is try and parse a term. Token iterator. So, and I don't even think I need to like perform lookback for these cases. So I want to parse a term which won't like term will only parse multiplies, I think. So it won't actually, like, that's the thing, we need to avoid infinite loops here. It like this term parse should parse this first part of the expression, and then we want to get the plus, and then we want to parse the other term, which could be 5 times 8 or something. Okay, so we want to then token iterator dot next expected plus expect plus. For now, just plus. We will later have different ones. Wait, I don't actually need the index. That's just because it'll look ahead. I have to do this as well. So, and then we can iterator as well, and those will be question mark thingies. So now we need to would you please let me? Thanks. We need to parse a term. Just it has the exact same syntax. So let's actually check. We get an expression. Yeah, we get a binary operation out of there. However, now a term will only try and parse a multiply. So I'm blanking on this again. Like my other code was using some callbacks. That's rather complicated. Let me actually look this stuff up again. Okay, screw it. Here's the code that I'm referencing. It's also in Rust, luckily. So what I have here, this is the function that parses an expression. And it first tries to parse a term separated by plus or minus. Now this bin-op helper, which takes a callback for parsing the sub-expressions on the left and right side. What it does, it tries, it gets a sub-expression, and then gets the operator, and then repeatedly, I think, just replaces, tries to do the same thing and gets another operator and parses the right side. It actually ever advances. And so I think this is the, like, it's not really recursive in the traditional sense. I think it's just it's just parsing the smallest amount of things on the right side or on the left side. And the sub-op here is term, which I can't do here. And term, of course, is just factor with multiply, divide, modulus. And that simply looks at, this is unary, that's a, and so factor does the inner part, where we get also literals. Up here we get parenthesized things, which is then again an expression. So for some reason, I can't, I thought that like factor had to explicitly call back, for its left and right side, call back into expression, but I guess not, because all that a factor can be is not like an addition, like a bare addition without brackets around it, because then the addition would be like separated from it in a way. It's hard to explain because the multiplication is more strongly binding, so it would grab the literal and leave the addition with like its entirety. I don't know if that made any sense whatsoever. So basically we want to parse a term. Actually, I think I'm going to replicate that. I'm going to write a helper function that parses me a binary expression. Parse binary operation. We'll get a token iterator, which is token stream. Get a result string, but now this also gets operation parser, which is a function that takes a mute token stream and returns again the exact same thing, our result type, expression, and string. And the operations, which can be like the exact same thing as here, token type. Yeah, so I think that's fine. So we can do this recursive thing. We try to get the left side, which is what we're doing here, though I'm like, I always have to have one. So yeah, basically I want to take this, put it down here, except left LHS is sub operation parser for the left side. and then let mute operation is then the token iterator dot next expected plus or any of. We actually get like the format. We can actually just take the operations here and just do that. Okay, while operation, I can just let okay operation equals operation. Now I need to rename that variable. Let me just really quickly, maybe. So while that is okay, now if the okay, so yeah, so what this does is if it wait, I can't use current token is not advancing, so I can't do a next here. I can just do a look ahead. Look ahead 1 index 0. Wait, no, I have to actually. No, I can't do this. This is not parameter. Okay, so now I have to operation index 0 dot type and then do the contains operations contains this. If not contains, and then we just break. So basically what we then do is just if we get another expression type, we bail out to the next higher expression. And I think that's what makes the multiply work, because the multiply will then once it sees an addition, it will bail out to the next higher one, which is the addition parser in a sense, which is this one, basically, this invocation of binop binary operation. These abbreviations back here are absolutely hideous. And this is one of the first pieces of longer pieces of Rust code I ever wrote. So that's why it's partially really ugly. So yeah. So if that contains that, then we can token iterator next. And then we can, the right-hand side is now a sub-operation parser token iterator. So now we know, because we have an operator, that there needs to be a right-hand side. And now we can just update left as the expression binary operation, and it contains a operator left-hand side, right-hand side. So operator is operation index 0. But we need to translate that into, we need to translate that into the other type. So we need to do the, I need to write something for that. So basically I need to, can I impl enum? I can do that in, I can do that in Rust. From token type. Token type, just a token type. Or did I put that into the Lexer last time? No, I don't have any code for that in Lex. I think I just did that manually for like the unary expression we had last time up here. Yeah, I just did that manually, if you can see my cursor here. My cursor is strangely disappearing on the recording. Sometimes I noticed that last time when editing. Okay, from token type that returns option of self, because might not exist, of course. So token type, I need to create Lexer token type. So I can now just self, and that's I can now just binary operator add. Wait, I'm dumb. Match token type. We don't have self yet. We're trying to construct something. So we want token type plus binary operator add. This is a pipe. And that's a self. Token type minus self subtract. Now, what is this complaining about? Oh, right, I need to do the... I did do that somewhere in the Lexer, I think. Yeah, up here. That's very similar sort of code. Okay. Well, start some self multiply. We can't actually parse divide right now. Oh, we don't have that, I think. Oh, okay, no, we don't have that. So let's just... so let's put in to do parse slash individual. So we won't actually get slash to parse today because we need to do some more Lexer work for that to happen. So let's just binary operator from token type. We need to include that, I think. Where are we? Down here somewhere. Yeah. Expected enum. You can just... No, I could just unwrap. Because I know that that it works because I've already checked. Or like if it doesn't work, somebody passed a token type in, or like allowed a token type that doesn't actually correspond to any binary operation. So that's then a programming bug. And programming bugs should generally panic. Like that's why Rust has the like result error handling and panic error handling split, because panics are for programming bugs. And if you know that a state is under correct circumstances impossible, and the other one are the results, which is like to be expected errors in normal operation. What we have here is we need operation 0.type, and we need left hand side is a RHS is box new RHS. Okay, that should be it. Right, and then we need to, of course, update the operator, or like, yeah, maybe operation is, and also, yeah, this is a bad name, by the way. This should be maybe operator. Token iterator, look ahead, one error message. This once more. Don't think there's a do while in Rust, otherwise we could do this more nicely, I guess, but I mean, look ahead for operator. We can do this. I don't know. Oops. Look ahead for operator. And here as well. That's another really nice application of lambdas, like just having this kind of common code inside a function that depends on a bunch of variables and you need to call in a bunch of places. Just having that a simple local function essentially. That's just a really nice way of using closures or lambdas. Rust likes to call them closures. I don't exactly know why, but they do. Okay, I'm missing something. I can throw away this code. No, and now I can just okay LHS, I think. Yeah. Okay, that might actually work. Now I wanted to rename. And the operation, and that doesn't work because Rust's too dumb for that. Okay, so I need to, yeah. That would be really nice if we had like these while-let and if-let renames. They don't work currently. That would be really nice. Hint, hint, Rust language server people, yak bait, Rust language server people. If any of them even watches my videos. Probably not, but you never know. Okay, so that's generic parse binary operation. So what parse term can do, it can just parse a binary operation of token iterator. The sub operation parser can be parse factor, I think, and the operators can be a token type. Oops, not a token. Yeah, a token type star, I think. Then take a reference to that and yeah, just return it. Now we need parse factor. I'm just like porting this code over. Now parse factor is the one that does all the internal parsing. So yeah, what does parse expression do? Parse expression, wait, before I forget, parse expression does the parse binary operation on token iterator, but like all the plus and minus things, like so yeah, it uses parse term, which are the sub operations of adding and dividing, of adding and subtracting. But the operators are token type plus, token type minus. Okay, and we need token iterator here. Okay, iterator. I think parse factor is one of the ones that... Oh, it only receives that. Okay. Yeah, okay. So the parse factor does the heavy lifting, or like it parses all the inner stuff after we've basically cleared operator precedence. So parse factor, if we get if we get a, yeah, if we get plus or minus, that is now a unary operand. If we get a literal, we just parse the literal. If we get a parenthesis, we start the entire thing over. So yeah, okay, let's try that. Okay. Equals token iterator dot look ahead. Just do a one look ahead, and we want expected expression. Let's say just expected expression. Let's do match token type for now. Yeah, I think actually just do x0. Okay. Type minus. Then we want to have a next. And then we want to parse another factor, which means I think we can just chain unary operators as much as we like, I think. Okay, yeah. So yeah, I don't think we want an expression here. No, I just think we just want factor here. Yeah, this will allow us to do cool things like negate an entire bracketed operation. Yeah, that makes sense. So basically the factor things are all of the least strongly binding ones. So of course plus is the most strongly binding of all of them, probably. Like, yeah, essentially we can just take all of the tokens that are... yeah, this won't work in the future with like not... Oh, no, because not is a keyword, so we can just token type not here in here if we want that. I think we get that for free. So that's cool. Let's operand is parse factor with a token iterator. No, why is it complaining about this? But yeah, because it's not getting anything. Oh, because yeah, I need to do it. Okay. Unary operation of token dot type and the unary operand, which of course needs to do this. Then I need to box that. And the yeah, now we need to actually do parsing here. So we need the exact same code for a unary operator. So we can implementary operator. Okay, just do the exact same thing. Self. So token type. And now yeah, I think I'm just gonna grab all of this. Don't need that. Where are we? That's plus, minus, and we don't have any others for now. So, from token type, this one, dot unwrap, because we already checked that. Okay, so let's token type literal. Let's grab our let's grab all of the integer parsing code we already had and put that in here. Should just work because we did a look ahead, so we can just do this like but yeah, I think we don't have to include a message here because we already know that there's a next value. Okay, then we could do the parenthesis now. Let's just expression, then do this, the token start of expression, and I want to quote that as usual, and also I'll probably want to do this. Parse factor. Do we have term, expression, binary operation? I think that might just work now. Let's see if that works. And we want a to expected. Wait, okay. Okay, no. The exact inverse. We just want that. And we don't want, the binding is already a mutable borrow. Where's that? The binding is already a mutable borrow. Remove that. Okay. Oh, I think now we have a lifetime. Or I just forgot to make that mutable. Where's here? Mutable left-hand side. Let's see the errors again. Cannot borrow book. Oh, that's because of the closure, isn't it? Yeah, that's because of the closure. But that is... Can I just force that to be mutable? Which escaped the closure body. Yeah. That makes sense. Yeah, I mean, I think at this point we just have to drop the nicety for making Rust shut up because it's not smart enough. Like, yeah, the closures often have these problems that the borrow checker can't figure stuff out. Mutable first borrow occurs due to use of token iterator in closure. Mutable borrow occurs here. Immutable borrow later used here in look ahead for operator. Yeah, so yeah, so if this, as you know, if I just now take this exact code and just put it in here and put it in here, everything is fine. Or at least it should be. It's not actually. Can I just make this mutable? Can't. Token iterator is mutable. Yeah, Rust C is strongly confused right now. Okay, so that actually wasn't a closure problem. That's just something, 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 something. Because look ahead is immutable. Now maybe operator is referencing. Oh, because maybe operator is referencing into the yeah, okay. Well, that makes a lot of sense. If it weren't for the fact that next isn't actually modifying the field that we reference here, namely the list of tokens. But Rust isn't smart enough for that. It can't figure out which fields were actually mutable, or yeah, it can't figure out that we're just mutably borrowing one field and not the other. Because if we're going through a function call, the entire struct will immediately be mutably borrowed because function calls are opaque to the borrow checker. Yeah. And it can't figure out, again, we have the same thing as a couple episodes back where it can't figure out that this running the destructor doesn't actually do anything except that maybe destroy the string. So I think what we need to do is somehow check beforehand that the zeroth, maybe, yeah, I think I just have to operator is the operator index 0 dot clone something, and now this works, and now we can just do that. And yeah, I just have to copy, and I think I have to drop maybe iterator somehow. I have to so that it isn't in scope anymore. Why doesn't that work? Well, it should know that maybe iterator is now, maybe operator is now, might be used here. Fuck you. I just dropped it, like literally, what the fuck? Token iterator. Immutable borrow might be used here. Well, I'm sorry, I just dropped maybe operator, didn't I? Okay, so I think maybe maybe operator itself needs to have a different type. So I need to, but like I can't actually die here if I don't have, if I don't have, oh, I can actually. Oh no, I can't because I need to, I need to wait. Okay, so what about copying? Oh, I need to, in that case. Why is it not, maybe because that doesn't change the lifetime of things. Because I think it's still referencing the same slice. Yeah, I don't actually know why this is happening anymore. Mutable borrow occurs here. Sure, I just copied things. Lifetime of this should not affect lifetime of token iterator anymore. Like that's the thing. I want to decouple their lifetimes and their borrow states basically. Like immutable borrow occurs here. Well, what do I have to do? Do I have to like? Oh, maybe because. Oh, I think I want to clone. Yeah. Okay, I want to copy the contents of the, because I can't actually. This is not sized because. Now that's what I'm trying to do. So I think I need to map a map the result. So I need to dereference those. So oh, it already does that for me, like for free. Okay. Yeah, I'm actually dumb. Like, yeah, right. So this only gets executed if we actually have a value. So I basically perform a copy if we have something, and otherwise I didn't perform the copy. So now I can just do this, and I don't need this fuckery anymore. Expected. Yeah. So this is actually perfect. I think that should work. Woohoo! I think that's it. Well, we have, this could be a const function, but that's a good sign because Clippy only shows up once the compiler is satisfied. Okay, so could insert a joke now. Clippy is afraid of the compiler or something. I don't know. Looks like that's working. It is. Oh my god. We have a parse of I'm so glad. This makes me happy. This is the things I go programming for. Let's check that, of course. So we have plus, so unary operations still work. So we have binary operation of add. The left hand side is 0. The right hand side is a this, okay, so we have an add, and then we have an inner add of 5 on the right hand side, and 7 times, oh no, that's the outer one, right? That's the outer one. Right hand side 5, left hand side everything else. So this one, and then we get 0, and then we get 7 times 3. Fan flippin' tastic. That's 45 minutes right there. Yeah, maybe I should stop now. Although Maybe I want to, no, don't need this anymore. Let me close that repository, please. Yeah, okay, so I think we can just commit all of that in one massive commit. Backtrack. Did we ever actually use backtrack? Wait, let me check. Did we actually ever use backtrack? I don't think so. Oh, yeah, we did. Okay, so did we ever use make substream? We also use make substream. Okay, I guess we need all of them. Yeah, I think we need, like, for expressions, it's with this magic trickery that I don't 100% understand. It's possible to parse without backtracking. But I think at some point we might need that just for convenience. It's probably possible to parse without backtracking, but it might be more complicated. Yeah, so I think we can add all of this and also add this. Bootstrap parse magic expressions. Okay. Cool. Let's write some tests. Also, before I do that, let's first kill this and get in a git commit amend no edit. Okay, now let's write some tests. Or rather, let's actually check the performance of our things. Okay, I think that's 2.25 nanoseconds per iteration. I think that's about the speed we got last time. Oh, it's running much longer. Yeah. So let's actually write a test. Expressions. Test parse expression. So I think what we'll do is actually write a quick little AST walker evaluator. Just so that we can like evaluate, like that's much simpler. Then we can just give it something to parse and tell it what we expect as a value. Okay, so let's create AST, get then AST, a node, which is an AST node, and we get back a N64, so I64, or is it 128? No, it's right. We're doing 128, don't we? Yeah. Okay. Literal U128. Why am I doing U128? This should be I128. That's kind of dumb. That is actually dumb. Yeah, so this should be I128. Or it might fail, of course. No, it might not. It might not fail. Let's just have it always succeed just for the test. So let's get a node. so can we actually wait? Okay, so I need to thought it was possible. Do I have to import AST here? Oh right, okay, I have to actually do that because that's basically like template arguments or like generics just in a slightly different way. So you actually have to know the type of AST, so the actual implementer type when you call this function. And otherwise it is not callable because you can't, like basically for every single impl you need to generate different code because the type is different size, because AST is just a trait and that has no known size. So if you actually want to pass anything at all, even if you don't know it at compile time, you need to use box because you don't know the size. But in this case, I think it's fine because if we get a let's just take expression. Wait, we just want to take expression. Evaluate expression. I'm dumb. All that explaining was for nothing. Because expression is an enum that has a known size. It is size, probably. Yeah, okay, so natural literal. That gives us value, just returns the value. Unary operation with unary operator plus and a value, returns the value. That returns negative value, though I think that's an expression. Yeah, okay, so I need to actually evaluate that. Like writing this kind of evaluator is like ridiculously simple in comparison to like parsing the damn thing. And also like this kind of code I've written a bunch, so that's not super hard. Expression, binary operation. Let's go first with value, LHS, binary operator, add, LHS, LHS plus evaluate expression, right hand side. So, oh, right, I need to unbox here. And this is a bug, by the way. This should be red, but that's because there's a ligature in here. Oh, I need to struct pattern syntax. Okay. I need to dereference both of those as well. Oh wait, I can just... I'm gonna need that 2 more times for subtract and multiply. Cool. Expression. I think that's all. It doesn't like it because we can't... Yeah, I think... Yeah, let's just add divide. We can't parse that yet, but we can evaluate it. So that's divide, and what is missing? Oh, unary operation not reference and dereference are not covered. Unsupported expression for evaluation. Okay, so cert equals Parse expression went lexer lex some code here. Let's just go with, I don't know, 15, negative 15. And also, or can we just question mark that? I think there's some way to do that. Expected token stream found back. All right, we need to do the same kind of stuff that this does. Yeah, okay, so we don't want to use parse because we only want to parse bare expressions, but we need to do something very similar. So I think we want to do this. Expected slice. Expected string. Expected reference. They are okay. Don't worry about that. Does lex? Yeah, okay. So it's just confused at the moment. Why can I not? sref. Is it not? Fuck my life. Why can't I just take a reference to a static string? Expected string found in stir. Do I have to string this thing or to own something? Oh, and I have because that's how I designed lex. Yeah, that's kind of dumb. Actually, I should just take a reference to a string slice. Let's not worry about that right now. So I think I need to, what does this do? Oh, I need to bracket that differently because I need to first question mark operator it. Fuck my life. This function returns a result. Come on. Oh, in a function. I have to wait. Yeah. I think that's supported for tests, like having them return results and basically fail if the result is something that's bullshit. Let me actually create a closure for this. So okay, so the closure must return string to result of bracket string whatever that in okay. And the return value is a token stream with static lifetime. Okay, and the only reason that I'm doing this is that I don't have to write all of this out every single time. So that I can just say create tokens 15 question mark. Expected struct string part stir. Oh. So now we should only, yeah, okay. Mutable. Oh, can I just, yeah, I can just do that. Okay, and now we can do a bunch of these, like this should be -50 and this should be, let's just use our example here. -4, and up here we have 7 times 3, which is 21 plus 5 is 26. Yeah, so here we have 8 times 0 plus 4. This should just be 4. 22 minus 6 times 6 times 8, so that's a bit much. 6 times 2, which is 12, should be 10 plus 1, 11. And let's do some like something like this. Wait, no. Let's do that with subtraction. 2 minus 2 minus 1. So if we bracket this correctly, it should be 2 minus 2 minus 1. So 0 minus 1, which is minus 1. If we bracket this as 2 minus 1, it's 2, just 2 minus 1, which is just 1. So that should work, but let's see if it actually does. It doesn't compile because binary operation cannot be applied to type result expression, and yeah, so we want, wait. Oh, because parse expression, oh, I need to evaluate, of course. It's kind of dumb. To here, that probably won't work. No, it doesn't. Fuck, this never works. Now it does. Okay, so I need to question mark those. Blah, 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 blah. Returns a value referencing data owned by the current function. Yeah, for fuck's sake. Why can't you just be normal? Oh, because the token stream is gone, of course. Yeah, because it is. Yeah, okay. Oh, I just want a simple solution for this. Let me just yeah, token stream static doesn't work in that case because xor.lex because the token stream doesn't own the data anymore. So we actually need to have like, let's have token streams or something, which is a vec of token. So we're just gonna store the data there. And then we need to make this a bit more complex. So we need to grab that. Wait, we need to token streams push this. Does that work? Expected function pointer found closure. Oh, because not. What is it not liking? Token streams. -1 or something. I don't know if that works. What the hell? Wait, what am I pushing here? No. I want to push this. And if that's just referencing the outer function and that lifetime is removed, expected function pointer found closure. Well, yeah, what is the type of the closure? That would be nice to know, because the for prime error are yeah, no. I need to annotate this with a lifetime. Those two can have different. Fuck, how does that work again? Last time it worked like this. How about I just rip out the entire fucking definition? Yeah, this is... It's a... can't use negative integer. Yeah, I need to compute the index. I need to borrow here. Just I need to not borrow here. I want to, yeah, unnecessary parentheses. Okay. Okay. The error, it cannot infer type for parameter. Type for type parameter e declared on the enum result, because it can't figure out that this question mark is running on something with an error type string. Okay. Can I and string? Is that possible? It is. Now, what is it referencing? It is only referencing token streams, isn't it? Why is this so hard? Yeah, fuck off, fuck off, fuck off. Returns a value referencing data owned by the current function. No, that's not the case. I'm referencing token streams. Oh, because fuck my life. It think yeah, okay, so code to owned is can't have that. So we need to lex needs an end string. So we need to do this. Okay. Need to actually like we need to take all of these. It dot to owned. Okay, and now it complains about the captured variable again because I don't actually need to do that anymore. I can just take the code. I am not capturing it. Which fuck's sake, which implicit variable is that capturing? Turning this value requires that primed to because it's not liking. Yeah, because I need to actually use that here. They have the same lifetime, and I can't have a undeclared lifetime use in-band life. Cool. There's an experimental feature for that. Now, what about I static this? Static this, static that. Let's just static this. Borrow expression cannot be associated with, cannot infer an appropriate lifetime, but I cannot annotate it. Well, that, I think that contradicts itself, but either way. So that closure can access token streams, but the lifetime must be valid for the static lifetime. Oh, right. So I need to probably how do I explicitly Oh, I need to vec plus prime a static. Yeah, oh fuck that. Just can't have prime static, which is no. Because so I can't annotate this with being static. Can I not annotate that? Like this is like I can annotate lifetimes, but apparently I cannot annotate lifetimes enough. So what I want is basically all I want to say, okay, well, this string and this token stream live as long as this thing so that the entire closure can live as long as that. And that is a solvable solution for the borrow checker because it knows how long this variable lives. And it lives for all of these things. So that is like, come on. Can I not? do this. Or do I actually have to function string that returns a result? Looks like this. I thought. Okay, let's Rust lifetime parameter for closure. Yeah, that's exactly it. Okay. Yeah, I could use a function instead because lifetimes are closures have concrete lifetime parameters, which is, yeah, it's fair, to be honest. So copy this over. So it's just const cannot const mute const ref is it ref mute or something? What's that? Mute ref. How does that work? Ref. Boys, I just want a global variable. I said, yeah, oh, it's static. Okay, static. Static mute. So I don't need that. Oh, I need to actually keep the type right. Just forget. No. Code is lifetime prime A. Now I'm getting into territory that I actually do understand. So basically the static. I think that's what I want. Yeah, fuck mal. We might as well just yeah, it cannot be unsafe, so let's just wrap an unsafe block around the entire damn thing. Because of course I know that it's safe. That's too owned because because I don't actually want to do that. Yeah, because all of those terms are not static. And Lex requires fuck it. I need to change this here now, because and Lexer state's code needs to be a stir, because that actually doesn't change anything at all, not even about the lifetime. Where's the code coming from? Expected struct string found. Okay, everyone just calm down. We're using string references, which are better anyways. Okay, so that actually worked without any problems. I think main just, yeah, that was kind of dumb actually. So expected. Now I can just stir this. And now I can just remove those, remove those, remove that, remove that, remove that. I think that's it. Yeah, okay. Token streams. Like, the only reason that this damn function exists is that I wanted to encapsulate stuff. I could have also just written a macro, for fuck's sake. Would have probably been faster. Now we get a failure, which is, of course, much better. Index out of bounds. Because I cannot program. That's the end of the episode. These tests all pass, even the ones that are intentionally difficult or intentionally try to break parsers that are not 100% correct. So let's end the episode here. This was way too much time fiddling with the borrow checker. I hope you learned something from that. Until next time, goodbye.